Hi everyone, in this video we will talk about audio module. The first thing you should know that we can representing any sound as analog wave like this red wave here. And because there is many values in this analog wave, so we can't store it in memory. To overcome these problems, we will take samples from this analog wave. As you can see here, this is the first sample and the second one, etc. And you should know that the number of samples in each second, we call it sample rate or sampling frequency as well. After that, we will apply pulse code modulation PCM to obtain digital audio inside audio file. Before we go further, you should know that the number of sampling frequency or sample rate should be greater than the maximum frequency in this audio signal. Now we have this audio file which has many values. Each one of these values represented in 16 bits. The range of these PCM 16-bit signed values from minus 32,768 to 32,767. After we learned all these basics, let's go back to audio module. You should know that there is two functions inside this audio module. The first one is decode wave function and the second one is encode wave function. This decode wave function is scaling all values inside audio file to be from -1 to 1. And this function will return two tensors. The first one is the audio tensor and the second one is the sample rate. There are a bunch of arguments inside this decode wave function. The first one is contains. It is tensor type string. It's just the audio file itself. The second argument is desired channels, which is optional argument, accepts integer numbers, default -1. The next argument is desired samples, which is the audio length requested. Let's say we have an audio file with 10 minutes and we need just the first minute, so we can use this argument to take the first minute from this audio file. The last one, name, it is the name of the operation. It is optional argument. Now let's go to encode wave function. This function has a bunch of arguments. The first one, audio. The second one, sample rate, and the last one, name. This function encodes the audio data using wave file format. It will generate a string that will be suitable to be saved out to create .wave audio file. It will be encoded in PCM 16-bit format. Encode wave function takes in float values from -1 to 1, and any outside to that value will be clamped to that range. The first argument, audio argument inside this encode wave function, is just a tensor. The type of this tensor is integer 32. It is two-dimensional tensor. The first dimension is the length and the second one is the number of channels. The second argument, sample rate, it is just a tensor with type integer 32. This tensor has one value, which is the sampling frequency. The last argument, name, which is the name of the operation, it is optional argument. The encode wave function will return tensor type string. As you can see here, the encode wave function works the opposite of decode wave function. So now let's go put all these concepts in practice. Here we have audio dataset, and this is audio file. Inside this dataset, we will take one of these audio files. Let's first import TensorFlow. Now let's make variable. Let's call it file path. This variable equal to the path of one of these audio files. Let's say this file. After that, we will make sample rate variable. Let's say this variable equal to 32,000. So now we set the sampling frequency. After that, we will set the maximum duration. So max underscore duration equal to 5. So here we will take the first 5 seconds from this audio file. Now let's read this file. So audio equal to tensorflow.io.read_file, open parenthesis. Here we will put the path of our audio file. Now it's time to use the decode wave function to convert this audio file into tensor. So audio, sample underscore rate equal to tensorflow.audio module.decode underscore wave, open parenthesis. The first argument contains, which is the audio itself. So type audio here. Let's set the desired channel argument equal to 1. This argument, desired channels argument, will change the number of channels dimension in the output tensor. And let's make the desired samples equal to sample rate multiplied by maximum duration. So we can take the first 5 seconds from this audio file. Let's print audio. As we said before, audio is just a tensor. The type of this tensor float 32, and the range of values inside this audio tensor will be between -1 and 1, as you can see here. The first dimension is the number of samples, and the second one is the number of channels, which in this case 1. If we make it 2, let's see what's happening here. As you can see here, the length of the second dimension now is 2. Now let's use the second function, which is encode wave function. First, audio equal to tensorflow.audio module.encode wave function, open parenthesis. The first argument equal to the output of decode wave function, which is audio. The second argument, sample rate, sample underscore rate. This one here. As you can see here, the output of encode wave function, it is just a tensor of type string, which is a PCM 16-bit format. Now we learned how to use TensorFlow audio module to encode and decode audio files. Thanks for watching.